Today, the ds-incubator continues on the series about testing our code, and it might be the last meetup of this series. I wanted to talk about an idea that was captured by the phrase text fixtures in two places. One is a vignette in the test.dat package, and another one is a blog post by Jenny Bryan in the Tidyverse blog. It originated from a conversation that was internal in our studio, and they realized that it was very useful beyond that environment. So they wrote those resources, which I find very useful in our context, because I usually feel that particularly the code base that we know as Pacta is very difficult to test. It's kind of as hard as it gets, to be honest. I read a whole book about testing that kind of refactoring, that kind of challenging situations, and yet it kind of checks all the boxes for super hard. Sometimes what makes the situation difficult to test is that the code changes the state of the ecosystem around the code. Like, for example, set up an environmental variable, right? Or change the working directory. Those kinds of things change the state in which the code runs. And that means that if you want to test one piece of code, and if that piece of code changes the state, then the next test will already start in an awkward state, right? So you have to clean up. So basically the process that we should aim for is, okay, we start with a state, we change the state however we need to test that piece of code, and then we restore the state to what we found it, right? So basically this idea that most tests are written assuming that the starting state is a particular one, and then if you leave your environment changed, then the next test will not have the assumed state, right? So we have to be very careful about restoring the state to the default state. And this is the idea that I wanted to talk about. I'm not gonna be able to get too deep into it, so that maybe package developers have something actionable. You will need, if you're a motivated package developer, you will need to probably read a little more in the blog post in the Tidyverse blog or in the vignette in test.dat. But yes, I do want to at least mention the hazards of changing state and how we could address those hazards and how to leave the world in the state that we found it. That is because every test, we want to start from scratch, basically from a blank slate. So the first thing I wanted to show with a demo is how, for example, we could write a little function that changes the number of digits that print to the console when we run, for example, pi, and how a sloppy of such a function could change that permanently, not just for the call of that function, but in general. And that's bad, because if we call that function once, the next time everything will have changed. So basically, this is what I want to demonstrate. Say that we have this sloppy function here. Maybe I'm gonna make this a little bigger so that this is there you go. So we have defined sloppy. I have not called it yet. And let's see what number prints to my console when I call pi. So pi is just an object in R, comes with R. So when you print it, it prints the number pi with some significant digits, which are defined by default in the, however your logo, your options have been set. In this case, it's printing 1, 2, 3, 4, 5, 6, 7 significant digits. But now I'm going to call my sloppy function that takes a number and applies the number of digits that I give it to the second argument right here. So my sloppy function, what it does is takes calls the function options and changes the option digits to whatever significant digits I want. So in this case, I call sloppy with the number 2, so I would expect that the number of significant digits is 2. And here you can see on the console to the top right that instead of printing 7 significant digits, it printed only 2. Okay, so far so good. But what happens if I count pi again? I would expect in a normal R session, you would expect that a function that you called before wouldn't change how the number pi displays after you call that function. However, if I print pi now, I still get 2 significant digits when I was expecting 7. So this function sloppy changed the options not only for the duration of that call, but for the entire session, right? So if I want to recover the number of digits that I had by default, I need to restart my session, and only now I could call pi, and I would expect the 7 number of digits that are set by default. So why is this a problem and how it relates to testing? Okay, if for example, we have a piece of code that does something like this, creates a change that is general, say you set a global environment variable, or you change the options of some particular option in R, and you write a test for that piece of code, then the starting state of the next test will have changed, and the results that you will get there will probably be different from the ones that you expect, and not because the piece of code is kind of wrong, but because the starting state is different, right? So you would start getting false positives in failures, like basically failures in your test that are not indicating that the code is wrong, but the starting state is wrong, and that's very difficult and challenging to work with. So how do we go about solving this problem? Okay, there is a function in R called onExit that is the common function that we use to solve this challenge. Basically, if we wanted to write now a neat version of the sloppy function, so it's basically the same thing. We set the options to a number of significant digits, but now we are going to store that. We are going to assign that to an object, because options has a very kind of unexpected, and maybe some people don't know much about this, but options does 2 things. It sets the option to whatever you give it, but at the same time it returns the older options. That means that if we have in OP the options that were at the start before we call options, that means that we could use those options to restore them after the action that we want to make. So we can then combine the function onExit, right, with a call to options OP. Basically what we are doing here is that when this function neat exits, now we are going to set the options to what they were before. And that solves the problem with 2 caveats that onExit has. And now we're going to be kind of basically spending the rest of the meetup talking about those caveats and how we can solve them. The first caveat, and probably the milder one, is that onExit needs these 2 arguments. The defaults of add and the default of after are not usually what you want. Kind of explaining that is a little takes a little while and maybe not super interesting, but you just for now just accept that these 2 arguments are generally most useful if they are not set as their default. So the default of add is false, and usually we want it true, and the default of after is usually true, and usually we want it false. So that's the first caveat of our function. So for now, I'm going to just demonstrate that neat does what we expect. I'm going to make sure that I restarted my R session, because the sloppy function before kind of messed up my environment, right? My options. So I'm going to define neat. I'm going to now call pi. I get the 7 significant digits that I was expecting. Now I'm going to call neat pi with 2 significant digits, so I expect only 2 significant digits, and there they go. And now what I expect is when I print pi, I again get the 7 significant digits that were set before. If that's the case, then my neat function is doing cleanup after itself. Let's run that, and there we go. We do have 7 significant digits, meaning that neat effectively changed the options just for the duration of itself, right? So it does the thing and then restores the options to what they were before. So that strategy is the most important point of this meetup. So calling onExit, or an alternative to onExit that I'm going to demonstrate in a moment, is exactly what I want to preach for. If you are a package developer, you may go like a step beyond that, and you may write your own what's called test fixtures, but we won't have maybe time to talk a lot about that, but I'm going to point you in the right direction. Now, the second caveat of onExit, the first one being this one here, that it has two arguments that the default are not usually very helpful. Instead, you need to set those arguments as defined here. But there is a second caveat that is even more important, and that is that you cannot wrap onExit on a helper. So if you say, okay, cool, this action of doing something and then restoring it to its current state is very helpful, and I want to have that as a wrapped feature and apply it to my test or apply it to whatever, then you could write your local digits function. You could do, write your little helper that does something and immediately destroys it. Basically, what you want to wrap is those two lines of code that I showed you before, where you set the options, at the same time you store this first line here, at the same time you store the older options, and then on exit of whatever you're doing, you restore the options to what they were before. That would be great. The idea is amazing, but unfortunately, you cannot do it with onExit. So let me show you that. I'm going to restart my session here to start fresh. So if I define local digits, and now I want to reuse that wrapper inside that function neither that I wrote before. So now instead of like basically using this code in line 30, I'm now using my wrapper. So you would expect that it would just work because you usually wrap code and it just works. But in this case, it doesn't. Because onExit does not have a way to go back one step up to the level where it's running. So it's running in the environment of local digits and has no way to step up to the environment where it's called inside the function neither. So let me demonstrate that. So I already defined neither, and now let's call neither. And as you can see, in local inside neither, I call local digits with the number 1, meaning that I would expect that when I call neither, the number of digits that I print to my console is just 1, and it's not the case. It's giving me again the 7 digits that are set by default, and that is, once again, it may sound a little weird, but if you're interested in digging more in the blog post, it's kind of explained more gently. onExit does not have a way to go up to the environment where neither calls it. It just exits here when you call local digits. That's the challenge. So there is a solution to that, which is to use a different function from a package that is dedicated precisely to manage state. And that package is called withR. And the function that replaces onExit is the function called defer. Defer already has those arguments that I showed you before set to what's usually most helpful. And it also has a second argument that is the environment, where you define where that function will do the cleanup, in which environment. So usually what you want is the parent frame. So that is kind of an implementation detail for most of us. The takeaway is that if you're struggling with the function onExit, use the function defer from the withR package. So let me show you what this, how this works. And I'm approaching to the 20 past, and Jackson is gonna try kick me out. I'm gonna resist that for a little bit. So I have just defined the function local digits. Remember, this one now is not using onExit, it's using the better, more featured function from the withR package called defer. So I now call, and I also notice that, okay, and also remember that the function neither was defined with local digits 1. So by doing this here, I'm overwriting local digits. So it's no longer be using the local digits that use onExit. It's now going to be using the local digits that uses defer. So I would expect that because defer solves the problem and can be wrapped, now neither pi should print just one significant digit that is that comes from here. This one logical significant digits, right? So let's try that. Let's run this line and see if that's. Oops, I think it looks like I haven't defined. So let me run everything on top. I'm gonna define neither. I called it before and it didn't work. And now I overwrite local digits with the function defer, and I call it again, and here we go. Now it does work. It's printing the one local digit that I wanted, right? Before I continue, if I continue, I would like to make a pause here because I acknowledge that it's 20 past and this is the time where we stop and ask questions. You have seen everything that is the most important part, so even if we stop here, it could be useful. So let's check with you to see if there are questions or comments here.
Can I just quickly verify that when you use the parent frame as an environment, that's not a default setting, that's something that you have to do explicitly?
Great. Let's see. I think that, let's see, with our defer. Let's see. I'm not sure if this is your question. So the defer defaults to the parent frame, but that's, I mean, you can change that. Is that the question?
Yeah, I guess that's the question, because then that seems a bit dangerous, because then that's like quite different than what you would expect if you're used to using on exit. So you have to be quite aware of that, I guess.
I think parent frame is also the default of on exit, right? I mean, it's not given as an argument, but the parent frame is where you're calling that function. So not the environment of that function, but its parent. So basically where you're calling it.
Right, okay, so when you pass an environment which is passed in from the parent frame of the calling function, then it's like the parent of that.
I think so. Let's look how here,
okay.
I know I'm passing the, to my local digits, I'm passing basically the default of the fare. I think that even if we remove...
Yeah, but at this point, this parent.frame is like evaluating technically in the function that's calling local digits, so it is.
Yes, exactly. Yeah, and that's why the fare. Okay, then you're right. It's not the default of on exit, because if it was, these local digits with on exit should have worked. So I think by passing parent frame,
I think it is. I think it is the same. It's just because like the parent frame that you're passing into the local digits.
Yeah.
Is like the parent of the local digits function.
And when you call it
into defer, which is now not the parent of the defer function, but it's the parent of the function that contains the defer function. So it is like
exactly
basically by default the same. You do have to pass in that environment, so that makes a lot more sense to me.
Yeah, thanks. Yeah, because it's a relative thing, right? That's right. So parent frame will always kind of be whatever it's the parent. Yeah, that's cool. Okay, thanks, CJ. That was a very cool question. Anything else to ask or comment on?
I have a question that's not strictly related to this, but something that you did in this that's always sort of confused me a little bit. And we talked about it one time, and I still don't fully get it.
Yeah.
But just when you're calling the original options, I always get confused, because it seems like if you're setting options, if you say like OP is options with this new option, and then you're recovering it again by calling options on the OP object. Should the OP object, I mean, like I know it doesn't work like this because I've seen what you're talking about work as it should, but shouldn't that OP object have the new options in it?
Yeah, no, actually, because it's, I mean, you would expect that from your experience with R, because most functions return, R being such a functional oriented language, usually you take an object, you modify that object, and what you return is a modified version of that object, kind of. Or if you return invisible, usually what you return is, for side effect functions, usually you return invisible the first argument. So basically you return the input unmodified. So those are the two scenarios that are most common in R, and options is just weird. So that's all you need to know.
Okay.
Options returns.
I think if you look at I think if you look at the help file of options, it like explicitly says we do this precisely for this reason, because you might want to do this.
Yeah.
I also wanted to flag that for anyone else who was confused by that, because I remember even just reviewing code sometimes being like, why does this work?
Yeah, that's very true. I think it does deserve like a more gentle explanation. It's however very common, because options doing this cleanup is very common. So. But still not as common as to find it like in everyday life, right? But if you do see some help files and you find options, I think it's helpful to understand how it works. So thanks to Jackson for that comment. So basically, if you don't understand options after this call, after this meetup, read the help file, because it is just a very weird function which returns invisibly the older options, not the newer options. Any other comment or question here? Okay, let's see how far we can get then. I'm gonna move a little more. So now I'm gonna show, I showed the sloppy version, the one that used on exit. No, the sloppy version was the one that did not use on exit at all. There was a neater version that used on exit, and then we had to change those parameters to the defaults to change the defaults to the values that we usually want. Then I show how to do that with the function defer. And now I'm gonna show you that the with R package also includes some wrappers already. So we try to write our own local, remember that we wrote our own local digits, which was a wrapper around those 2 lines of code that we were discussing just now with Jackson, where we set the options to something new, we store the older options in an object called OP, and then on exit, we restore the OP options, or the older options. So we wrap that in a function that was called local digits, but you may want to do that pattern in many other scenarios. So there are some scenarios that are very common in programming life, like for example this idea of changing local options or changing options and then restoring them is pretty common. So with R already includes a wrapper that sets that's just that. Instead of writing those 2 lines of code that are kind of confusing, you just call the function local options, and when the function that calls it exits, it will restore the old options to what they were before. So that's an alternative to the function options in this case. So let's define neatest, and let's call pi with let's ask to print pi with 3 significant digits. And there we go. And now if we call pi, we would expect, because this is a neat function, we would expect pi to print the original 7 digits that I have set by default in my R session. And there you go. So that works just as you expected. And maybe to connect this back to testing, this is the use case that I was kind of trying to explain, or that I aim to explain for those who are testing our code. So these functions, the local something functions, work not only in functions, but also work in tests. So let's say that let's pretend that we are in a test file. So I'm gonna attach the test.package because I need it. If this was a test, I need it here. So the starting state of my code is that where, for example, if I print exponential 1, so that the what do you call the logarithm of base 2, I think, of what you get is this number with 7 significant digits, because those 7 significant digits are set by default in my R session. So that means that, say that I want to mess up a little bit with my local digits, with the number of digits, and I want to call it, I want to test that local digits works when I ask for 3 for 1 significant digit, and it works when I call it with 3 significant digits. So basically I'm testing that local digits function, and that's fine. But what I want to happen is first to check that it works. So if you read more carefully, maybe after this video, the expectations here, you will see that, okay, so when I set it to local digits 1, I do get just basically the 7 significant digits are rounded to the number 3, and when I call 3 significant digits, they are rounded to the number 2.72. Okay, but the one thing that I want you to take away is that if you do use these local functions, then the state of this environment after the test should be the same that it was in the beginning. Remember, in the beginning of this test, before the test, I had 7 significant digits. I messed up with my number of digits, and now I print again my exp1, and what I get is again 7 significant digits. Conclusion: these functions allow you to leave the world exactly as you found it before each test. And with that, I ran out of time. Maybe the last second for a comment or question, and otherwise we say goodbye. Okay, thank you very much. Then I'll take that as there is nothing to add now. I know that it might have been confusing. Very keen. If you are very keen on pushing this to the next level and using these ideas in packages, feel free to do a help desk with me, and I'm very happy to help there.
Thanks, Mario.
Ciao, ciao.